working, we can start. Alright, let's look at Gloria and Sarita, okay? So what method does it look like they used? Graphing, substitution, or elimination? They plugged something in? They look like they used elimination, right? Okay, so what did both of them do in order to get 3x?
Subtracted negative 3x plus negative.
The x's, dear.
I plugged it in negative.
Added or subtracted? They did not subtract. That would give you 9. They added. Negative 6 plus negative 3 is 3. Alright? So then what's negative 4 plus 4?
0.
Okay, on both of them. And what's 26 plus negative 17? Guys, it's math class. You should have a calculator. Get your calculator out. Positive 9. So right there, you should see who's right and who's wrong. Who's right? Gloria's right. Okay, so let's write that down. Okay. 1. Yeah, no, we added. But we'll just say added because we need to know that's not up there. Because she... Okay, this focusing thing is out of y'all. I'm about to have a fit over here. Yeah. She correctly added 26 with negative 17 to get what? Positive 9. Very good. Very good, very good. Alright, now, if you have 3 different colors, a pencil and 2 different colors, it might help you to see what's going on 14. Because all we're going to do is we're going to graph all 3 of those on the same graph. So, you have x greater than 0, right? How in the world do you graph that? Where do we start? Origin at 0. And x and a number means we get what kind of a line? Off your phone. Don't say it like a question.
Vertical.
Vertical. Beautiful. Say it with some confidence, like you know what you're doing, because you do. Alright, then from there, it says x greater than. Guys, how do your x's get greater? To the right. I hope that's on the phone when I see it. Alright, so which way? To the right. There you go. Okay. Alright, then you got another one. You got y greater than 2x. That has a y and that has a 2x. So that means that we're actually going to have a slope. It's going to be an identity graph, right? So what's my slope?
2.
Nope. 2 over 1. Yep. And what's my y-intercept? 0. Perfect. So we're going to start at 0. Go up 2 and right 1. Or we can go down 2 and left 1. Doesn't look like it. Solid line or dotted line?
Solid.
Yeah. Alright, now this one's different because this one says y greater than. So where do your y's get greater? Your y's go up and down. Up. There you go. Do you see where that shading is starting to cross now? Yeah, see right here where they're starting to cross? We still have one more to do. Alright, so on Friday, you made yourself 3 little notes. One about graphing, when to use graphing, one about when to use substitution, and one about when to use elimination. So when we are graphing, what has to happen before we graph? Y has to be by itself. Very good. So we're going to move the 2x over by subtracting. All okay so far? All right. What's your slope?
-2 over 1.
Yeah. And your y-intercept? Beautiful. So we're going to go up 7. does our slope tell us to do?
Go down to the right one.
Down 2 and right 1. Perfect. Okay, so solid line, right? And it says all the y's less than. So y's go up and down. And where do the y's get less than, guys? Down. And see, when you did it in color, it's kind of easy to see where all 3 of those shading crosses. Where do they all 3 cross? I know. But you see this point right here, this place right here where they all shade together? Okay, that's where they all shade together. So we did A, said to graph, we did that. But B says determine the vertices. Guys, what are vertices? What points? Of the triangle, right? So this one's easy. What's this point right here? 0, 0. There you go.
6,
0, 6.
Oh, that's 7.
That's 7. Very good. 0, 7. All right, and then somebody was saying that this guy right here is a decimal, right? Okay, so that's fine. We can use the substitution and elimination that we did last week. So what equation is the yellow line? There's 3 equations. Which, very good. It's the one that has the yellow writing next to it, right? Y equals 2x. So last week we didn't use any less than's or greater than, so we're just going to use equal signs. Oh, okay. Get it in for you.
One of those is plus is -2.
Not 1. What's the green one?
It's 2x plus 1.
Very good. 2x plus y is equal to 7. Now the reason we're going to change them to equal to's, off the phone please, is because now you can easily see from Friday what we need to use. We have a letter by itself, so what tells us to use, which one do we use if we have a letter by itself? Substitution, very good. So we're going to take what y equals and plug it in for y. So you had 2x plus 2x is equal to 7. What's 2x plus 2x? 4x, yeah. Divide, and we're not going to do a decimal.
7 over 4.
Beautiful. So we know the next one has an x value of 7 over 4. Okay? All right, then we have to plug that back in to find y. Math workshop test is next week, so hopefully we've got both of these problems on our paper. If not, that's going to be a test grade. So grab your pencil. Do number 14 with us. Grab your pencil. Do number 14 with us. On your paper. So, which one do you want to plug into to find out what y is? The top one? Okay, it doesn't matter. So we'll do y equals 2 times 7 over 4. Make 2 a fraction, you put it over 1, right? What do you get when you multiply those? 14 over 4. Those reduce. Very good. There we go. Beautiful. Okay, math workshop test next week. That will be your last test grade. No, excuse me. Chapter 3 will be your last test grade. And so we got 2 tests next week. We have this math workshop test, which will probably be on Monday. And then we have Chapter 3 test, which will probably be on Thursday or Friday. Okay, you all good? All right. This week we have a quiz on 3.1, and it'll be on Wednesday. Okay, so if you want to make yourself a note of that somehow, it'll be on Wednesday for your quiz. All right, we got a lot to review today. We're going to review our ACT from Friday. So let's look at that, 15 and 16. Sir. All right, look at 15. Now, guys, remember on ACT, the only thing we're worried about is the actual question, not everything that it says. So what's the actual question on number 15? All right, so what are the two important things about that? Very good. What is area, guys? Beautiful. But then I have to find the area of the shaded region as well, okay? All right, so let's see. Adrian, the whole entire thing, how many boxes are the whole length? 8. And Clay, what's the width of the whole thing? 6. Beautiful. All right, Thomas, now we're going to just do the shaded part, okay? So what's the length of just the shaded part? 7. And Katie, what's the width of just the shaded part? How many boxes? 5. Beautiful. And then, guys, all they did in your answer was they compared them, right? So what are your two lengths? Let's see. Diane, what are your two lengths up here on 15? 8 and 7, okay? So, Luke, which answer choices do not compare 8 and 7? Which answer choices do not compare 8 and 7? Which ones don't have 8 and 7 here? Okay. That's it? All right. So, Addie Kellogg, we're going to compare our widths as well. What are my two widths? Uh-huh. Beautiful. All right, so Cameron, which one compares 7 and 8 with our widths, and 5 and 6, 7 and 8 with our lengths, and 5 and 6 with our widths? E. Perfect. Y'all okay? You multiply these out?
Yeah, like that's what I did.
Okay. I mean, that's the same thing. You can do the extra step. That's fine. That's fine. All right, 16, last one, guys. Here we go. So it says that A is 48, and it tells, yes, sir. You would multiply this and get 35, and multiply the bottom, and then you would do the same thing on these two, and get the same thing. Yeah. Yeah, that's fine. Hey, sometimes, even though it may be more steps, sometimes if it makes sense to you, you may be able to do it quicker that way. So. Yes, all right, let's look at 16. 16 told us that A was 48 and that AB was equal to AC. Y'all okay with that? All right, and in geometry last year, you had a theorem that said if those two sides were congruent, what do you know? The two angles are congruent, right, Luke? Okay, so if we don't know what those two angles are called, like we don't know how much they are, what can we call them? In math when we don't know something. X. Yep. I'm going to add those two x's together. Ooh, I meant to underline it. There we go. Yep. And you would get? Beautiful. Perfect. And you would get? Perfect. Look at you go. Y'all okay?
I did a little different though, but
Why does the 2 differences on -5 is not All right, let's look at homework from Friday was page 4, numbers 4 and 7. 4 through 7, excuse me. 4 through 7. No, page 4, numbers 4 through 7. And we're just going to look at the answers today. We're not going to turn them in because you're going to need them for just a minute. So answer for number 4 should have been 3, -1. It's bracket. I'm not going to give you a whole piece into the bracket. You will look at the bracket between the 2 and the 5. What's the difference between them? Okay. Are there any issues on 4?
Yes.
I ran into the desk. It'll be all right.
Just what?
5, yes.
I believe I'm making substitution.
They should be right there, unless I missed one. All right, number 5, you should have gotten all row numbers.
Yes.
You should have gotten something to the effect of 0 equals 0, something like that. They equal each other. All right. Anybody have an issue on 5? Anybody need me to come to them?
4?
Ma'am? You need 4?
Yeah.
Okay, when we do independent work, I'll come help you. Let's see. Number 6, we have -1, 4. Anybody need me to come to them in a minute and help them with 6? Yes? Okay. Wait, are we having that many issues? Okay, several of us are having issues. Okay, so I worked with the x's. 4 and 3, I need them to be 12. So multiply that by 3, multiply that by 4. 12x minus 15y is equal to 51. 12x plus 16xy is equal to 20. Get these, I need to subtract them. 12 minus 12 is 0. This is -15 minus 16. -31. And I have 51 minus 20, which is positive 31. Divide and you get -1.
Okay, yeah.
Do I need to keep going? Yes or no? No? Okay. Do I need to go over 5? Anybody need to go over 5? Okay, 6. So I'm going to get the y's to be the same because they're smaller numbers. So that would be 15. Okay, how do you make 15 and 15 go away? Subtract. So 30x minus 24x is 6. 30 minus 36 is -6. Divide and you get -1. Anybody need me to keep going? Yes? Okay. Let's see. I'm probably going to plug in the top one. So 6 times -1 plus 3y equals 6. Y'all okay?
Can you come see me after all this?
Yes, I'll come see you. It's probably a sign or something. All right, number 7, you should have gotten 4, -1.
Wait, I did.
So these 2's are already the same. So I'm going to go ahead and subtract. -3 minus 2 is -5s. 11 minus 6 is +5. Divide and you get -1.
Oh, okay, I see that.
So I need to keep going? No? Okay. Anybody have issues? Oh. Oh, okay. All right, let's turn to page 11 real quick, and that's what we're going to work on with our partners today, and then we got a checkpoint after that. Page 11 is on the board. I do not, Bonnie. I do not. You should just be able to bend it back when you got him. Okay, thank you. All right, let's go back over this. You ready? Here we go. Let's go back over this real quick. Numbers 1 and 2 want you to solve by graphing, which means what has to happen? Thank you, Cameron. Y has to be by itself. So right now, make yourself a note. Y has to be by itself for 1 and 2. Y has to be by itself for 1 and 2. Make yourself a note. All right, number 3 says to solve by substitution. What do you have to solve for substitution?
The number that is by itself.
No. What, Cameron? Variable by itself. Does it matter which variable? No, doesn't matter. So you gotta have a variable by itself. Make yourself a note on number 3. Make yourself a note on number 3. What? Life is stressful, especially this week. Okay, elimination. So when you have elimination, what are you looking for? Same number, same letter. Very good. Same number, same letter. Did you get all those notes? As in, like, all those ones that you're writing down? On page 11? Okay. All right, 6 and 7. Last ones, guys. 6 and 7. You ready? You get to pick which one. So you either get to pick to use elimination, or you get to pick to use substitution. Does that make sense to everybody? You might have any issues? All right, find your partner. We have about 15 minutes to work out 7 problems. 15 minutes to work out 7 problems. All right, Mark. Where we at? Here's number 1. You'll get the same answer for number 1?
Yes.
No, we did not.
Yeah. Do we have to write down almost an independent?
Yes.
Okay.
I know it doesn't tell you that too, but you'll need to know that for your test.
Yes, ma'am.
Dalton, do we need to go over?
Just the first.
Just the first one. Okay, so you have 1x minus 3y is equal to 6. So we're going to subtract 1x. So you have negative 3y is equal to negative 1x plus 6, right? And you divide by negative 3. And so that's y is equal to 2 negatives make a positive, 1/3. 6 divided by negative 3 is negative 2.
I'll do it.
You sure? Okay. All right, so guys, when you had this one, I need to know this point right here where they cross. That's important. That's the solution. You got with me? So what is that point right there where they cross? Beautiful. And what did we call that? Consistent and independent. Beautiful. Yes, ma'am. All right, keep going. All right, guys, there's number 2, okay? There's number 2. Y'all okay with that one? All right, what do we call that one when they're parallel? Inconsistent. Beautiful. Everybody good so far? You good for a quiz Wednesday so far? Okay, so far. Let's keep going. Did y'all solve the top one for y and get negative 3x plus 7? Yeah, so far? Y'all okay? All right, and then we're going to, Luke, you okay so far? Okay, so then we're going to take this piece right here, and we're plugging in there, right, for y? Good? All right.
Okay, bet.
Got it? All right, keep going. See what you can do. Katie, how you doing, baby? Okay. Okay. Macy, we good, baby? No. Do you need me? You figured out what you did? Kenzie, how you doing, baby? Okay. Oh, I got one, baby. So when you use substitution, you have to have a letter by itself, right? This guy right here is almost by himself. So how do I move this 3x to the other side? Subtract. You get negative 1/10.
Oh.
Okay, we'll go just a minute.
So we're not doing that.
Hey.
Oh, kidding.
Alright, so Belle, look, baby. You plug it in right here to the y, and you distribute, you get negative 6 plus 14. Then you added these two and got negative 2. Or, excuse me, you subtracted those two and got negative 2. And then you subtracted the 14 and got positive 2. You got negative 1.
Oh, wait. I did it right. I just did it the other way.
What do you mean you did it the other way?
I eliminated.
Oh, it says you got to use substitution when it says to. Have to. Alright, any issues on 3? Anybody need me for 3?
Yes.
Where?
This should be 4x right here. So I had to get one x under go when you got 42. Like, y's had to equal or the x's had to equal. So I chose the x's because it was just 3. And so I multiplied the bottom by 3 to get 3x minus 3y. Yeah. For 5, did you get the solution?
So that way it cancels out. Is it not like 8-1 minus 2?
Eight y minus a negative 3y. It does not matter. Because 3 times negative y. Oh, yeah. So let's add. Oh, so 3 minus 3 is 0. So we have no negatives.
No.
Oh, I think
Now divide it over 4. Alright.
No, it's like,
so
I was
it's
gonna
8 minus
come up on
6,
4,
right?
but A, so it's.
And see, I did it that way first.
But like, you can't have a fraction.
And then this is like negative 6 minus 27. So it's negative 3.
Crazy. There. Yeah. Because if you write like that, it looks like there's a negative 3 to subtract. Okay, right? Three on the screen. Yeah, 8 minus negative. Positive what? Wait. Oh, negative 2 plus 6 is B. Yes, 1. And you got negative 6 minus 27. Oh my goodness, I did it right.
Alright, hold on, let me put this over here, and I'll look at it.
Do you want us to multiply like 3 times? Do you have to multiply by 3?
I prefer you just multiply by a positive. It's not wrong if you do the negative, but when you do the negative, you're more likely to get one more thing wrong. So I just like to do the positives.
Okay. So
But it is not wrong if you like to do it that way.
Does it matter?
Yes. Okay, look, 3 and 3.
You just have to cancel one of them out.
Look, 3 and 3. I wouldn't add those because they wouldn't eliminate. That'd be 6.
So you
I'd have to subtract them. So you kind of have to look and see what you're given. Okay.
did you understand any of it?
Okay, we're going to number 5. All right, did y'all check your answer for number 4? Make sure you got the right thing.
Oh my goodness.
Did you get it right again? Look at you go. Yeah? What? No, it says negative 6 minus 27. Everything is being subtracted. Okay, 3 plus 3 would be 6. That would not eliminate. Okay. Negative 3 plus 3 is 0. That's what I would add on the next one. What, Luke?
I don't understand how to do substitution. I forgot how.
Okay, hold on. All right, check your work on 5. Are y'all okay on that one?
Yeah.
Coming. All right, we'll do our checkpoint tomorrow. We've got 2 minutes. Let me put up the answers for 6 and 7 real quick for you. Hold on. Yes, you're going to finish this at home, okay? Let me put up the answers. Hold on. Let me finish this and I'll be right there. All right, y'all get B equals 13? And then A equals 15? Wait, is that right?
Yes. No, I got 9.
Wait, hold on. Hold on.
Yeah.
O equals 3, not 9. There we go. That's a 7. There we go. Did I get 9 and 7? Okay. All right, then this one. Good. Check your answers before you leave. Check your answers tonight, guys. Bye. Have a great day. Mark, I hadn't forgot about you. Don't worry, okay? You're done?
Whatever you did.
Put it in the tray then, okay? I know you can't get out. Hold on.
They can finish now. I'm going to have coffee.
Yeah. I can't even think. I'm like, what am I even doing? Hold on.
And then when you plug it in,
5g plus 4, negative 5, 10. 20 is 10. 5g is 30. G equals 6. 6 negative 5. Did you get that?
yes, ma'am.
Okay, sweet. Alright, hold on.